Guys, this is Sanjay from FTC Team 7477, Super 7. Today, we are going to be talking about another sorting algorithm, selection sort. It's based off bubble sort, except slightly more efficient. Let's start by giving a quick recap of the code. First, we can start by the method declaration. The method is public static, means it can be called without creating an instance of the class main. It doesn't return anything, which is indicated by the void character. Instead, it modifies the input array, which is this, ARR, as a parameter, directly. Next, let's talk about this line of code. Int n equals r.length. We can calculate the length of an array and store it in a variable n. This makes it easy to refer to the size of the array throughout the whole method. For example, let's say our array has seven elements, right? Then int n would just be 7, the length of the array. Next, let's talk about the outer loop. This loop iterates over the array and divides it into two parts. The sorted portion at the beginning and the unsorted portion that we're still working on. The variable I represents the starting portion of the unsorted portion, min index. Initially, the sorted portion is empty, and the unsorted portion includes the entire array. With each iteration, one element is a move away from the unsorted position to the sorted position. At the start of each outer loop iteration, we assume that the first unsorted element, r of I, is the smallest. We store it in its index in the variable min index. Next, let's talk about the inner loop. The inner loop starts from the element right after I and checks every element in the unsorted portion. Here, the variable j helps us iterate through the remaining unsorted elements, starting from I plus 1. If we find an element smaller than the current minimum, we update min index to sort its position, as indicated by this line over here. Inside the inner loop, we compare array of j with array of min index. If array of j is smaller, we update min index to point to this new smallest element, which is what this line does. By the end of the inner loop, min index will store the position of the smallest element in the unsorted portion of the array. Next, let's talk about the swapping element. Let me just code that. Now we know the smallest element's position. It's time to swap it with the first unsorted element at position I. To do this, we use a temporary variable called temp. First, we store the value of array of min index in temp. Then we assign the value of array of I to array of min index. Finally, we assign the value of temp to array of I. This swap block of the code ensures that the smallest element is moved to its correct position, which grows the stored part of the array by one element. Next, let's talk about the main method. This is where we actually define our array and we actually call it selection sort. So let's just take a random array of some numbers, right? Let's say we have 5, 8, 1, 2, 7, 26, 17, 89, 100, right? This is not at all in order. So we can call selection sort R, right? Now we can actually see the result of all of this work. We can print it out by doing for, since I and j are taken, let's just use k equals 0, k is less than array.length. Since n isn't defined in the scope, length k plus plus, right? And now we can just print, so it's this one. Actually, there's a shortcut in IntelliJ. You can just type SOUT and enter. So we can just print array of k. So let's try it with this array here. We can run it and the array is fully sorted. 1, 2, 5, 8, 17, 76, 89, and 100. This shows how selection sort is an efficient sorting algorithm for small sets of data like the one I have here. However, similar to bubble sort, selection sort isn't that viable for larger sets of data. I hope this taught you something about selection sort and various other sorting algorithms. Thank you for watching and be updated for more new Super 7 content.